Bling. Yeah, so I want to just do this problem which we were kind of unable to do last time, and this is a fundamental question. We know why it is fundamental. Here is the problem first. Okay. That is, show an equal to 1 plus 1 by n to the power n is increasing. Right. So just restated it. These are the same things. This is less than the next term, en plus 1. Just put n plus 1 in place of n, and you get your. So these are the same questions. Yeah. So did anyone make any progress in this? Comparing it to E. No, you can't compare it to E. That is not going to work. Don't compare it with E. Because it will not work. E is just a limit, but that doesn't mean that this sequence increases to it. But anyways, yeah. So Ishana, did you make any progress? Could you get anything, any ideas in this for this? No. Okay, yeah. So it does turn out that this problem is a little difficult. It is not completely, I mean, the usual proofs you will see of this problem, the usual techniques, and I mean, you will be able to do this when you do those topics. There's a calculus proof, which you consider the function where the input is x and the output is this. And there are some very powerful techniques to study its growth rate and so on. Calculus say, yeah, this can be done. Okay. Yeah. But assuming we don't want to use that, others are some heavy manipulation, which some tricky manipulations you will find. This is a standard theorem which is present in many books, which can also be used. Okay, some manipulation. But today I was just trying it. I was just trying this by the binomial theorem, just because I was thinking, I mean, let's see if there is any way in which we can do this, right? Because induction did not seem to be very useful, right? We were trying last time, assuming small case and growing, it doesn't seem to be very amenable to that. So I was just thinking about the binomial theorem because this is something that we know, right? Expansion, and it's just based on a previous method. So again, since this may again be a little novel, so let me try to say what I mean. The idea is to expand both sides. Okay, I want to expand both the sides using the binomial theorem, and then I want to compare. That is the idea. So can any one of you come forward and tell me how would you expand the left-hand side with the binomial theorem or otherwise? Yes. Yes. Mm-hmm. Yes, obviously. Yeah, that's right. That's right. Yeah. So that's perfect. Yeah. And you can go on like this. Let's write a 3, 4. Right. So let's just write 3 terms. There are more terms. That's not right. And then you can similarly do for the next one. So we can bring it a different color. So maybe this is still a question mark actually. So this will be just same thing, just n will get replaced by n plus 1. So So then we have n plus 1 choose 2. And yeah. So now can we compare both the sides term by term and see what happens? So obviously when you see these two things, the left side, right side, obviously the natural instinct is to compare term by term, right? So let's try to compare both the sides term by term and see what we can say. So try it and so comparing, yeah, let's see. So what do you guys get? Obviously comparing first terms, and this is trivial because it's actually equal, and these are also equal. These are actually equalities, no doubt. They are both 1 and 1, 1 and 1. So just compare the third terms and see that just a square term. It should not be difficult to compare. I mean, you would know what to predict. You would want to say that this is bigger than this. So just write it and do cancellations and see if it's true. That should be simple. Yeah. Mm-hmm. Mm-hmm. No, you should know if you cancel 2 factorial and n factorial, I mean, yeah, if you want to simplify this and factorial by 2 factorial, so you should know what you will get. Just do the expansion. So write it. I mean, if there's any confusion, you write it. So write it in full and then divide by 2. And then you ask yourself, if I cancel this, then what is the remaining thing? Is it n minus 2 factorial? No, right? Because it starts from 3 and ends at n. So it's obviously not n minus 2 factorial. Or so yeah, so it's, if you just get confused, just write it and see. I'll just take n equal to small number and see. You can write. No, but I mean, we don't want to use this, right? We already know the simplified meaning. We already know that n choose 2 is n into n minus 1 by 2, right? Right? Is this okay? Ishana, is it okay? Is this? Yeah. Yes. No. Not okay. Yes. Yes. Oh, sure. Yeah. So so both of us know the usual definition, right? We know that this is n factorial by n minus 2 factorial 2 factorial, right? This is what we know. But then you want to do some simplifications and see, right? Now this is also, we had used this thing in earlier thing where we had simplified it in use. So that's how we usually will use it. So you can just simplify. You can write this, and then the rest is n minus 2 factorial, right? Because it's n minus 2 down. And then here you have, yeah, right? And this is just, and you can also see that choosing two things is like this, basically. You can see it either. I mean, in general, you should remember this, and you should ask yourself why this comes, either by cancellation like I have done, or you can try to prove it directly. But just keep this in mind, because this is very important. Okay? You can keep it in any way you want, but this you should have, right? So this is an important, I don't even want to call it a formula. This is what it is. This is, it's nothing new, it's just the cancellation of the. Okay, so please remember this. This is a very important one, and you will see that this is true. Okay. Right. So that's fine. Now that we know this, okay. So this way we are also learning the properties of n choose R like this. I mean, the various ways in which it can be written. So when it is this, right, then what is the third term? Well, let's write out. Let's write it out, right? So this is n into n minus 1 by 2. And then further we are doing this, right? And on the right side, on the right hand side, we have just by the same thing, right? You have n plus 1 and then 1 down. And then you have 2 and then you have plus 1 square. Now compare these two things and tell me which one is bigger. So you want to compare. So this is a question mark. Right? Can you give an explanation? Right. Right. And so you get this on both the sides. Right. That's perfect, right? And this is obvious. Just cross multiply and you get, right? Cross multiply this with this and so on. So this is a very obvious obvious thing. You see, so this is the power of cross multiplication and so on. This simple rules that we know how to manipulate things tells us. Otherwise, it is not very obvious that I mean, we don't have the insight to see this directly, that this is lesser than this, right? But after manipulations, after cancellations and so on, we can say we're able to say. Good. So this is just a small manipulation, so we know this. Now it's a homework, and you should do. Check that for this happens for every R. Okay, so we have and choose 2 times, and hopefully I'm correct. Okay, you can check it. I think this will work. This. Okay. Similarly, now this may take a little more work, but you have to do. But please do the calculations. Okay, then only you would know how to cancel and so on. Okay. Similarly, check for n choose 3. First you do for n choose 3 if you get more comfortable, and then do in general. So this is n plus 1 here. Pay attention. Now this is n plus 1. I wrote n by mistake first. And you obviously would know this is, yeah. So most of the things you would know immediately if you if you just have a look at things. Okay. So I'm not really doing anything. Just the maybe a good idea is first that you expand both sides and compare term by term. That's the idea. Other things are just the expected things. Similarly, check this and so on for general R if you can. Okay. So please try at least for 3, 4 you try, and you should be able to write for R and try to cancel and see. Otherwise, we will definitely do this next time. But I want you guys to put some work here first. Check this. This is homework. Okay. So do this. So, but do you guys agree that if we can do this, then our problem is solved? Okay. So you see, the binomial theorem is a really powerful thing. Okay. It's just such a simple thing, right? Just expanding and choose R's and so on. How many times you get something, and when you multiply, how many times you get x to the power R. This simple reason, but then it just changes the complete game, right? Because we understand these things much better than we understand this block big thing. It's strange quantity, addition and power and so on. So binomial theorem is really thing. Just this combinatorial way to expand. And I guess it was invented, people say Newton's binomial theorem, right? Something like it was invented in calculus, basically maybe to prove some limits. There also it's used because just this being able to expand things just makes it help you to analyze things. Yeah. Right. So this is one very beautiful application, I would say. Okay. So then let us see what we can do next. Just give me a minute.